Hello students, today we are going to discuss GJMAT 21-22 questions for grade 7. Alright, before we start, I will just take you through the exam's format and the exam guidelines. So this exam had 25 multiple choice questions, MCQ questions, okay, with 5 options for each questions, answer options, out of which only single answer is correct. Question number 1 to 10 had conceptual understanding questions which were 2 marks each. Question number 11 to 20 were on application ability, which were typically word problems with 4 marks each. And question number 21 to 25, that is 5 questions around problem solving skills, which were non-routine problems. These were 8 marks each. Okay, the duration of the exam was 60 minutes, 1 hour. Okay, and apart from that, you are not supposed to use calculator. Okay, so without further ado, we'll start the paper. You can always pause the video and try and solve these questions. You are allowed to keep rough sheets for arriving at the answer. All right, so we'll start with the first question. So the first question from section A, conceptual understanding section. 98, 122 and 158 when divided by a natural number n gives the same remainder. Find the largest possible value of n. All right, so let's understand this. When 98, let's say the number is let's say the remainder is, sorry about that. So let's say the common remainder, it is the same remainder. All right. So when 98, 122 and 150 are divided by a natural number n, it gives the same remainder. All right. So let's say 98 is divided by n, and this gives me some quotient a and some remainder r. All right. This means that 98 is equal to n times a plus r. Similarly, for 122, you will get some other quotient, let's say b, will be n times b plus r. All right. And for the last number, which is 158 also, you will get n times c plus r. Okay. Now, these are 3 equations over here. Okay, so what does this mean is that if you subtract 122 minus 98, 122 minus 98, that will give you n times b minus a, because the r's will cancel out. So the difference between 122 and 98, which is equal to 24, it will give you n times b minus a. Now b and a are quotients, so they'll be integers, correct? So b minus a will be also an integer. So n times some integer is equal to 24. And similarly, if we do from equation 3, if we subtract equation 2, we'll get 158 minus 122, and that will give us n times c minus a, and the r's will cancel out. And that is equal to 36, which means that n is a factor of both 24 as well as 36, because n times some integer is 24 and n times some integer is 36. Largest value of n, we need to find the largest common factor of 24 and 36, which is the HCF. To find the HCF, we can make it out that it is 12, but let's say we do not know. So what we can do is that we will take 24, prime factorize it. We'll get 8 times 3, which is 2 cubed times 3. All right. And for 36, we'll take 4 times 9, which is 2 square into 3 square. All right. And we'll take the common primes. So the common primes are 2 and 3 both, and we'll take the smaller values of these 2 primes. So the LCM, or sorry, the HCF in this case will be equal to 2 square times 3. So we'll take the smaller values of the 2 and 3. All right. And that will give us 4 times 3, which is 12. So the correct answer for this question is option 12. Okay, option E, which is 12. All right. We can check this out also. If you divide 98 by 12, okay, your quotient will be equal to 8 and your remainder will be 2. Similarly, when you divide 122 by 12, your quotient will be 10 and your remainder will be again the same, which is 2. Right? And when you divide 158 by 12, your quotient will be 13 and your remainder will be 2. Right? So as we can see that the remainder is going to be same, the largest possible value of n is going to be 12. Let's look at the next question. Question 2. Find the value of 27 raised to the power 2 by 3 times 16 raised to the power 3 by 2 divided by 32 raised to the power 3 by 5 into 81 raised to the power minus 1 by 2. All right. So here we see that these are all fractional exponents, and then there is an order of operations. Different operations are involved in this expression. Okay, and we have to find the value. So what we are going to do is that there is only one term in this which is got divided by, and the rest all are multiplication. So we'll keep this as a fraction and make this look like this: 27 raised to the power 2 by 3 into 16 raised to the power 3 by 2 into 81 raised to the power minus 1 by 2, and this is being divided by 32 raised to the 3 by 5. Why we can do this is because multiplication and division are both the same level of operation in PEMDAS. All right. After this, we are going to break this down, where we see that 27 and 16 and 81 and 32, they are powers of 2s and 3s. All right. So we'll look at this. So 27 is 3 cube raised to the power 2 by 3. 16 is 2 raised to the power 4 raised to the power 3 by 2. 81 is 3 raised to the power 4 raised to the power minus 1 by 2. And this is going to be divided by 32, which is 2 raised to the power 5 raised to the power 3 by 5. Okay, now in exponents, you know that a raised to the power b raised to the power c, okay, bracket raised to the power c is equal to a raised to the power b into c. All right, so we are going to do this, use this exponent rule here. If we open the bracket here, it will become 3 into 2 by 3. Okay, so 3 and 3 will cancel out. Multiplied by 2 raised to the power 4 into 3 by 2. The 2 will cancel out with 4 and 2 times. And 3 raised to the power 4 into minus half. And the 2 will cancel out over here as 2. Raised to the power 2 raised to the power 5 into 3 by 5. And the 5s will cancel out. All right. So after these cancellations, let's see what happens. We'll get 3 raised to the power 2 here. All right. So we'll get 2 here into, we'll get 2 raised to the power 2 times 3, which is going to be 6, into 3 raised to the power 2 in times minus 1 is going to be minus 2. And here we'll get 2 raised to the power 3. All right. So here we see that 3 raised to the power 2, and so in exponents we also know that a raised to the power b into a raised to the power c is equal to a raised to the power b plus c. Correct. So we are going to use the 3's. There are 2 3's here, so we'll club them together. 2 plus minus 2. All right. Multiplied by 2 raised to the power 6 divided by 2. So we'll remove, and in division, you know that what happens if you have a raised to the power b divided by a raised to the power c, it is a raised to the power, it is a raised to the power b minus c, right? It is a raised to the power b minus c, correct? So here we'll get 2 raised to the power 6 minus 3, all right? And this one will become equal to 3 raised to the power 2 plus, and here it is, sorry, it is minus 2 here. 2 plus minus 2 will become 3 raised to the power 0 into 2 raised to the power 6 minus 3 is 3. You will get 3. Now, any number raised to the power a raised to the power 0 is equal to 1. Correct? As long as a is not equal to 0. So here we'll get 1. 1 into 2 raised to the power 3, and that is 2 raised to the power 3, and that will give us 8. So your correct answer in this question is option B, which is 8. This can be done much faster, but just to explain, I have broken this down in many steps. All right, so let's move on to the next question. Question 3. Find the value of 4 by 3 minus 8 by 15 plus 12 by 35 minus 16 by 63 plus so on and so forth, 44 by 483 minus 48 by 575. So of course, this kind of question has some kind of pattern. So we need to identify the pattern first before we proceed, because otherwise, if we do not know the terms in between, then how can we, kind of take an LCM and try and solve this, right? So the pattern, if you notice carefully, if you first look at the denominators are 3, 15, 35, 63. These are all odd numbers. If you look more carefully, you will see that this one is 1 times 3. This one is 3 times 5. and this one is 5 times 7, and this one is 7 times 9. So basically they are product of two consecutive odd numbers. All right, and every time you go to the next term, there is one of the numbers is overlapping. So you have 1 times 3, and then you start with again 3, and then 3 times 5, and then again you start with 5, so 5 times 7, and so on and so forth. If you notice this one carefully, this one is going to be your 21 times 23, and this one here is 23 times 25, right? So you actually can find out the 575 because 25 times 24 is 600. So that gives you easily an idea that this one, and then you can go backwards and find this one out. All right. Another thing to notice about the numerators is that actually the numerators are sum of these two numbers. So 1 plus 3 is 4 here, right? Okay. And then you'll notice that this one is 3 plus 5. This one is 5 plus 7. And this one is 7 plus 9. So the numerators are sum of those two numbers, whose product is given in the denominator. Now this kind of series is also called a telescopic series because in this there is an overlap which happens, and many terms get cancelled out. Let's see how can we solve this one. Okay, so we take this term which is given there, and the first term we write it down as 1 plus 3 divided by 1 into 3. All right. Or let me remove the brackets. We don't require the brackets. We can just see that this is going to be 1 plus 3 divided by 1 by 3. And the next one is going to be 3 plus 5 divided by 3 times 5. The next one is plus 5 times 5 plus 7 divided by 5 times 7. And the next one here is 7 plus 9 divided by 7 times 9, and so on. Okay, and the last two terms here which are given here, there are many terms in between, and the last two terms which are given here are plus 21 plus 23 divided by 21 times 23, and then this is the second last term, and the last term is going to be 23 plus 25 divided by 23 into 25. All right. Now, what we are going to do is that we'll need to understand one more thing. These can be broken down into unit fractions. If you know 1 plus A plus 1 plus B, if you do, you get AB divided by plus B plus A, right? B plus A. So you can actually, and these are all in this form. So you can actually convert this backwards and convert them into these terms. So if you look at it in the first term here, will become 1 by 1 plus 1 by 3. The second one will become 1 by 3 plus 1 by 5. Third one will become 1 by 5 plus 1 by 7. Fourth one will become plus 1 by 7 plus 1 by 9. And so on. And the last two terms here will become 1 by 21 plus 1 by 23. All right. And this one will become minus 1 by 23 plus 1 by 25. All right. Now, when you open the brackets here, you will see that what will happen. So all the terms which have a negative sign before them both the terms will become negative. So 1 by 1 plus 1 by 3 minus 1 by 3 plus 1 by 5 plus 1 by 5 plus 1 by 7. All right. Sorry, this one will be a negative 1 minus 1 by 5, and then minus 1 by 7 minus 1 by 9, and so on and so forth. The last two terms will open up like plus 1 by 21 plus 1 by 23 minus 1 by 23 minus 1 by 25. And now you will see that terms are getting cancelled out. So plus 1 by 3 here, minus 1 by 3 will cancel out, and then minus 1 by 5 plus 1 by 5 will cancel out. So they are alternating, a plus and a minus, and then a minus and a plus, then again a plus and a minus, and then again a minus and a plus. The next term here will be plus 1 by 9 plus 1 by 11, right? So on and so forth. So they'll get cancelled out. So all these terms will cancel out, the plus 1 by 3 and minus 1 by 23. Only the first term here and the last term will be left. All right. And that will give us 1 by 1 minus 1 by 25, which is 1 minus 1 by 25. and which is equal to 24 by 25. So these kind of problems are called telescopic series because they have an overlap. As you can see, there is an overlap here. There will be overlaps here. And all these overlaps actually cancel each other. All right. So that's the reason why these series are called telescopic series. So the final answer is 24 by 25, which is your option B. All right. I hope this concept is clear to you. Let's move on to the next problem. Question 4. Convert the given rational number, which is in recurring decimal format, 571 is repeating, to the simplest form of fraction. And the number which is given here is 4.3571, and there's a bar given. The bar means that all these three numbers, this is the recurring part. The 571 is the recurring part, which means it keeps on repeating itself. For example, if we do a 1 by 3, we know it is 0.333 and it keeps on going infinitely. So this can be written as 0.3 because the 3 only is repeating. It can be written like this. All right. Okay. And sometimes you have more than one digit which is repeating. In that case, you can have 0. Let's say 345. Okay. More than one of them is, or let's say 45 is repeating. So you can either put a bar or you can put two dots. So the first dot indicates from where the recurring starts and the second dot indicates from where the recurring ends. All right. The recurring part ends. So in this case, this number which we have here, okay, let's call it x, and x is equal to 4.3571 and a bar is given. So the recurring part starts from 5 and it ends at 1, which means that this number looks like somewhat like this: 5.3571, then again a 571, and then again a 571, and so on and so forth. All right. So to do this problem, what we are going to do is that first we are going to multiply this by 10,000. Okay. We're going to multiply this by 10,000. So 10,000x will become, the decimal will move from here till the end here. So we're moving the decimal to the end of the recurring part. Okay. And that is the reason why we are multiplying by 10,000, because how many digits are there before the between the decimal and the end of the recurring part? There are 4 digits. So that's why we are multiplying it with 10 raised to the power 4. All right, to move the decimal over there. So this one will give us 43571.571 and so on. All right. Then we are going to again multiply the same number in such a way so that the decimal moves to the beginning of the recurring part. All right, to the beginning of the recurring part. The first time we multiplied it, moved to the end of the recurring part. This time we are multiplying to the beginning of the multiplier part. So for this, we need to multiply here with 10, correct? Because it's only one digit we need to move to the right. The decimal needs to move to the right. So 10x will become 43.571571. Now the objective of doing this is to get rid of the recurring part completely, starting from the second recurring. Okay. Now if you subtract from, these are two equations. So this is equation 1 and this is equation 2. Now if you subtract from equation 1, equation 2, you will get 10,000 minus 10, which will be 9990, that is 9,990x is equal to, so this part will completely cancel out because they are exactly the same. Okay, and over here you will get 11 minus 3 is 8, 6 minus 4 is 2, and then 5 and 4 and 3. All right, and therefore we get 9990x is equal to 43528, and therefore x is equal to 43,528 divided by 9,990. Now both are even numbers, so we can divide them by 2 and we'll get 2, and then we'll get 1764 divided by 4995. All right, and that's our final answer. Okay, so 21764 divided by 4995 is option A. Now, if you know how to do this, you need not do all these steps. Okay, the way to do this is very simple. All right, first of all these we did just to get the formula also. I mean, if we had applied the formula directly, all you need to do is to see first of all how many digits which are recurring. There are 3 digits which are recurring, 5, 7 and 1, correct? And that is the part which is getting repeated. So those many 9s you need to put in the denominator. All right. Then you need to see how many digits are before the recurring part after the decimal. So that is only 1 digit, which is 3, right? So you need to put those many zeros, as many digits which appear after the decimal and before the recurring part. So you get put a 0 here. All right. And then you take the whole number without any decimal. Okay, and only one time repeating, of course, because you need to show it that way. And then from that subtract the entire part which is not repeating, which is 43 in this case, without any decimal. So what will you get here? You will get the same thing what you got over here, which is 43528. And then once you've got the fraction, you can always simplify it looking at any common factors which might be there. All right, so that's your answer over here, which is 217644995. I hope this is clear. Let's move on to the next question. The expression of 100 factorial divided by 42 raised to the power x gives us an integer as a result. Find the highest value of x. Okay, first of all, let's understand what is factorial. So any number, any natural number n factorial means 1 times, 2 times, 3 times, 4 times up to n. Okay, it can, the n can be even 1 also, 2 also, 3 also, 4 also, but it's up to n. All right, so this is typically used a lot in combinatorics problems and all. However, this is a mathematical expression. Just like you have exponents, you have something called factorial. All right. All right. Now let's understand this. It says the expression of 100 factorial by 42 raised to the power x gives us an integer as a result. If this is an integer, which means that 42 raised to the power x is completely divisible in 100, right? Because some number multiplied n, let's say the answer here is equal to n, where n is an integer. This multiplied by 42 raised to the power x is giving me 100 factorial. Now 100 factorial is also an integer. So n is a factor of this, and 42 to the power x is also a factor of this, which means it's completely divisible, right? Okay. Now, once we have understood this, let's write this down, this expression, and expand this. So 100 factorial will become 1 times, 2 times, 3 times, 4 times, up to 100. And the bottom part here, as you know that a into ABC raised to the power a into b into c, a into b into c raised to the power x is equal to a raised to the power x into b raised to the power x into c raised to the power x. So the exponent basically distributes itself among the factors of that number, among the basically the product chain of that number. All right, so if the 42 is 6 times 7, so that's 2 into 3 into 7 raised to the power x. Okay, so we can then say that this is equal to 1 times, 2 times, 3 times, 4 times, all the way up to 100, divided by 2 raised to the power x into 3 raised to the power x into 7 raised to the power x. Okay. Now, given this as a base, let's try and understand that how we can, when we divide this number 2 raised to the power x, 3 raised to the power x, and 7 raised to the power x into this 100 factorial, how can we get an integer? For that, all you need to understand that all these numbers will have to be cancelled out. For example, let's look at 24. Okay. Now we know 24 is divisible by 6, correct? 24 is divisible by 6. Why? Because 24 can be written as 2 into 2 into 2 into 3, and 6 is 2 into 3. So all the primes involved in the product chain of 6 will get cancelled out over here, and you will get 2 times 2, which is 4. At the same time, 24 is not divisible by, let's say, 16. Okay, it's not divisible by 16, because what happens here, you will get 2 into 2 into 3 divided by 2 into 2 into 2 into 2. So 3 2's will cancel, and you'll end up with 3 by 2. Now this 3 is not a problem. The problem is this 2. Why? Because everything should get cancelled out in order it to be divisible. Otherwise, you'll get a fraction with a which is there, which is co-prime with the numerator. Okay, and you cannot cancel that. Okay, so that's the concept here. Now let's understand another thing here, is that here the 2's will appear very frequently. So the 2's will appear in 2, then again in 4, and then again in 6. Because 4 is 2 times 2, 6 is 2 times 3, 8 is 2 times 2 times 2, so on and so forth. So there'll be a lot of 2's in this 100 factorial, correct? So we can have a lot of 2's in the bottom also. Okay. Now let's look at 3's. 3's will appear a little less frequently in this factorial. 3 will be there in 3, and then 6, 2 times 3, and then in 9, 3 times 3. And so they are appearing a little less frequently, and therefore their count will be much less when we kind of break down these numbers in prime factorized form. Okay. 7 will obviously in that case will appear even less frequently. It will be the least frequent number out of 2, 3, and 7. The 7 will appear 7, and then 14, and the next one is 21, and so on. Okay. So what we need to do, the 7 will be least. So we need to have at least whatever number of 7's are appearing in 100 factorial in this, at most. Okay. We cannot go beyond that. Okay, because if we go beyond that, the 2's might cancel, because all three of them have the same power now, x, and x. Okay, the 2's, the 7's will not cancel out. The 3's and 2's still might till some extent. So we need to find out how many times the 7 appears in this. Okay, I hope the logic is clear in this. Okay, so let's see how many times the 7 will appear in this thing. So 7 will appear in 7 once. In 14, it will appear 2 times 7, so it will appear again once. And then in 21, it appears 3 times 7. In 28, it appears 4 times 7, and so on and so forth, till we reach 49. 49 is power of 2, correct? Of 7. 49 is 49, which is 7 square. It will appear 7 times 7. Okay. And similarly, again, for 56, it will appear 7 times 8. Okay. And then again, it will appear in 98, it will so on and so forth. And in 98, it will appear again 2 times 7 times 7, because this is 49's second multiple, right? So it will appear 7 times. So what we are doing, if you have to count the 7's which will appear here, we'll first divide 100 by 7. Okay, to see how many times the first 7 will appear. Okay. So in all normal numbers which are not a multiple of 49, it is anyways appearing one time. But in 49, it is appearing twice. Okay. And again in 98, it is appearing twice. But when we divide it by 7, we count the first 7 of 49 and 98 as well, because these are again 7's multiples. Okay, so what we get here is 14. 14 is the quotient, correct? So these many times the 7 will appear. Okay, because there are 14 multiples of 7 less than 100, correct? All right. Now, if we look at the 49's, to count the second ones, the second 7's, which is in 49 and 98, what we need to do again is to divide 100 here by 49, and the quotient is 2, correct? All right. So overall, the total number of 7's which will appear here will be 16. All right. Okay, give me a second here. Sorry about that. Okay, so we see that the total number of 7's which will occur in this 100 factorial term, when we break it up into prime factorized form for 7's multiples, will be 16. All right, so we can have, at most, we can have 16 7's in the denominator also. Because if we have more than 16 7's here, which means the x value, if it exceeds 16, in that case, 1 7 will not get cancelled out. All right, so the maximum value of x will be 16, and that's your answer, which is option D. All right, so we'll move on to the next question from here. All right, question 6. Find the correct possible value of a plus b plus c, where a, b, c are different positive integers in the below question. All right. Now, in this particular question, the word used here is correct possible value. All right. So, which means that there could be more than one values for a plus b plus c. Okay. So, first of all, let's understand this. If you have something like this, where this is 1 by 30, this is called a unit fraction, where the numerator is 1 and the denominator is a larger positive integer. Okay, this is called a unit fraction, and it is being broken down into as sum of three different unit fractions, right? Well, because why? A plus b and c are different positive integers, right? So one way to do it is that, first of all, you express the number 30, okay, or whatever number is given in the unit fraction, as product of three numbers. So maybe three different numbers. So what we can do is that we can have this as 2 into 3 into 5. All right. Okay. Now each one of them are going to be a factor of 30. Okay, then we take the sum of these three numbers. Okay, the sum of these three numbers. So that is 2 plus 3 plus 5, which gives us 10. All right. And then we take again 1 by 30 and we express this as multiplied by 1. And the 1 we can take as this sum. Okay, as uh, as 10 by 10. Okay, so we take the sum and we divide it by itself. So this is like multiplying by 1 itself. Okay, then the bottom part we multiply it straight away. So that becomes 30 times 10, which is 300. And the top part 10, we break it down into this sum, which was 2 plus 3 plus 5. So the top 10 is getting broken down into 2 plus 3 plus 5. The bottom 10 is getting multiplied by 30. Right? And then we see we can take this as a common denominator and break up this as fractions. 2 by 300 plus 3 by 300 plus 5 by 300. Now the advantage of this is that because 2, 3 and 5 are already factor of 30, therefore there will be also a factor of 300 as well, because 300 is 30 times something, correct? And then it can be cancelled with the denominator to find a unit fraction. So this one will become 2 by 300 is 1 by 150, 3 by 100 is 1 by 100, and 5 by 300 is 1 by 60. And therefore you get three unique values of A, B, and C, because we broke them down into three different numbers. Okay, so 1 by 150 plus 1 by 100 plus 1 by C, and therefore we can assign these as A, B, and C values, A, B, and C values. And therefore one of the possible ways to do this, the sum of A plus B plus C becomes 150 plus 100 plus 60, which is equal to 310. All right, and that is one of the options given here as well, C. So of course the other options won't work here. Okay, so this is one of the options. We need to understand that the smaller options 120 and 180 would not work also. Okay, but anyways, that's for the next time. Okay, but let's say if we had taken in some other options. Okay, so if we took 130 and let's say we say that okay, we take the factors as 1, 15 and 30. Okay, we can take any three factors. Okay, it need not be just a product, but it can be any three factors also, any three different factors of this thing. Or let's say we have taken 6, 15 and 30. All right, because these three are also factors of 30. All right, so if we add them up, we get 51. Right, if we add them up, we get 51. So we can multiply 51 by 30. That one will give us 1 by 30 into 51 by 51. Right, 51 times 30 or 51 times 3 is 1530. So this one will become is equal to 1530, and break up this one into the sum of these three. So it will be 6 plus 15 plus 30. So then you can write this 6 by 1530. All right, plus 15 by 1530 plus 30 by 1530. Right, so 6 will go in this how many times? It will go to 1 by 255. I think so. 2, 3, 35. 1 by 255. This one will be 102, and this one will be 1 by 51. Right. So the another possible value, for example, of 1 by 30 can be where 1 by 30 has been broken down into this thing. So there can be like this. You can take any three factors, different factors of 30, and work this out. You'll get different values of A plus B plus C. So here you can see very clearly that A plus B plus C is a much larger value. Okay. So anyways, for this particular question, we have taken down in a simple three factors of 2, 3, and 5. Okay, as a product chain, and we have tried to solve this. All right, so we'll do the next question now. Question 7. Find the value of n which is written in base 2, okay, in the below equation. 132 written in base 5 plus 200 and multiplied by 210, which is in base 3, divided by 102, which is written in base 4, is equal to n written in base 2. All right, so we have to find this value of n in this particular case. Okay, we normally work with number base of 10. Okay, when we look at base 5, so what is 132 in base 5? 132 in base 5 will be 1 times 5 square. Okay, because if you look at the value, this one is 5 raised to the power 0, this one is multiplied by 5 raised to the power 1, and this one is multiplied by 5 raised to the power 2. So this is 1 times 5 square plus 3 times 5 to the power 1 and plus 2 times 5 raised to the power 0. All right. So 5 raised to the power 0 is going to be 1 only. So this will be plus 2. This one will be 3 into 5 raised to the power 1 will be 15. And this one will be 25. Okay. So 25 plus 15 plus 2. This number is basically 42 in base 10. So this is 42 in base 10. Normally we do not write the base for when it is written in base 10, but still I'm writing it just for our understanding. 42 raised to the raised to base 10. 42 in base 10. Now the second number is here, the 210 is in base 3. The same thing we'll do again. So 2 into 3 raised to the power 2 plus 1 into 3 raised to the power 1 and the last digit is 0. So this is 210 in base 3 will be equal to 0 into 3 raised to the power 0. So 0 into something is 0 itself. This one will be 3 and this one will be 9 times 2, which is 18. Okay, so this number is 21. So 42 times 21. All right, so this is 21 in base 10. All right, let's look at the last number here, 102 in base 4. So 102 in base 4 is going to be 1 into 4 square plus 0 into 4 raised to the power 1 plus 2 into 4 raised to the power 0. So this one will become 2 into 1, which is 2. This one will be 0 here, and this one will be 16. So 16 plus 2 is going to be 18. So the number we are looking at, if you look at the expression and convert them all into the same number, divided by 18 raised to the base 10. Now we can just calculate it in base 10, and that will be 42 times 21 by 18. Now 21 by 18 is 7 by 6. If we divide them, both of them, by 3, 6 goes in this 7 times. So 7 times 7 is 49. So this is 49 in base 10. This whole part on the left hand side of the equation is 49 in base 10. Now we have to convert 49 in base 2. Okay, because that will be equal to n in base 2, right? So we have to divide this by 2. What do we get here? Okay, all right, so we get 24 and remainder is 1. All right, sorry about that. So 49, if you have to convert into base 2, we need to divide this by 2. Okay, and our remainder will be 1 and the quotient will be 24. And again we divide it by 2. Our quotient will be 12 and our remainder will be 0. Again we divide by 2, we get 6 and our remainder will be 0. Again we divide it by 2, with 3 our remainder will be 0. Okay, and again we divide it by 2, our quotient will be 1 and remainder will be 1. Right? So what you need to do is that you need to take the last quotient and all these remainders in this direction, and 49 will be equal to 110001 in base 2. This is in base 10 will be in 0. We can check this also. So this one will be, if you notice, this is 2 to the power 0, this is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 2 raised to the power 5. All right. So for 40, this one is 2 raised to, so 1 into 2 raised to the power 5 plus 1 into 2 raised to the power 4. The rest all is going to be 0, so I'm not considering that. Okay, 0 into 2 to the power 3. So anything multiplied by 0 will be 0. And the last is 1 into 2 raised to the power 0. So this one is 1 into 32 plus 1 into 16 plus 1 into 1. So this is equal to 32 plus 16 plus 1, which is 49. We verified that. So our answer is going to be 110001, okay, which is the value of n. Okay, so 110001 is option E, and that is the correct answer. I hope this one is clear. Let's move on to the next question. Question 8. Each of the interior angles of a regular polygon is 162 degrees. Find the maximum number of diagonals that can be drawn in it. Okay, so as the number of sides of a polygon increases, the number of diagonal also increases, right? So first we need to find out, and there is a direct link between the sides and the number of diagonals. Okay, so first we need to find out is the number of sides, correct? Now, how do we find that? This is a regular polygon. So regular polygons feature is that their sides are of equal length and their angles are also equal, correct? And how we can find out? So each one of them. So let's say this is a polygon here. We don't know how many sides here. Okay, and these are called exterior angles over here. Okay, so each of the internal angles here are going to be same, and therefore each of the exterior angles are also going to be same. Okay, all right. So now we'll see here that the interior angles are given as 162 degree, and the sum of each interior angle and its exterior angle is 180 degree. So 180 minus 162 degree, which is 28 degree, okay, will be the internal angles, exterior angles, correct? This will be each exterior angle, all right, will be equal to 28 degree. Oh, not 28 degrees, sorry, my mistake. 180 minus 162 is 18 degrees. 18 degrees, right? Now let's understand this, that the sum of all exterior angles is always 360 degree. And there are n exterior angles because there are n vertices and n interior angles also. If there are n sides. So n times this 18 degree will be equal to, and the sum of all exterior angles is always 360 degree. Therefore, the number of sides is going to be 360 divided by 18, which is 20. All right? Okay. Now we've got this 20 here. Now we need to find the number of diagonals. Okay, the number of diagonals, there's a formula for that, is number of sides multiplied by number of sides minus 3 by 2. This is the number of diagonals. Number of diagonals. Okay, and that is going to be 20 into 17 divided by 2, which is 170. Right? So that's going to be your answer, option D. All right. Now, why the formula is there? Let's understand that also a little bit, so that you don't have to remember the formulas. Okay. So let's say I draw a particular polygon. So there's a polygon here. As you can see, I've drawn a hexagon here. Okay. So let's label the vertices A, B, C, D, E, and F. Okay. All right. Now let's understand. Let's take one of the vertices A. Okay. Now how can I get a diagonal? The diagonal can be drawn to E, D, and C. Correct. Okay. So from this particular vertex, I cannot draw a diagonal here because that will make the side itself, and I cannot draw a line here also. These two will make sides. Correct. And I cannot make a diagonal with myself, own self. I cannot shake hands with myself, right? So with one vertex, I am able to draw n minus 3. As you can see, 6 minus 3 is 3. I'm able to draw n minus 3 diagonals. And therefore, if I have n vertices, because the number of sides and number of vertices are same, if I have n, I'll be able to draw n into n minus 3 diagonals. If I start drawing the diagonals from each vertex like this. However, in that case, I will be retracing a diagonal. So if I diagonal A to C, then when I'm counting for C, I'm doing a C to A also, which is the same diagonal. So we are double counting in that. And therefore, total number of diagonals is n into n minus 3 divided by 2. Right? I hope the concept of the formula is clear. All right, let's move on to the next question. Question 9. In the figure below, ABCD is a rectangle and O is a random point inside it. AOB is 15% of the total area of the rectangle, and triangle COD has an area of 175 square centimeter. Find the minimum possible perimeter of the rectangle if its side lengths are integer values in centimeter. All right. So we'll try and do this problem. Okay. First of all, what it is saying triangle AOB. So this O is a random point inside the rectangle ABCD, and triangle AOB, okay, it is 15% of the area. All right. And triangle COD is 175 centimeter. What we need to do is that in this kind of problem, any rectangle or a parallelogram, from this point, this random point, you draw a line which is parallel to both the other sides. Okay. So let's say we draw a line which passes through O, which is parallel. Now you notice that this particular rectangle is broken down into two rectangles, right? Let's call this as E and F. So ABEF is a rectangle, and EFDC is another rectangle which is just below it. Now you know that this triangle will be half of the top triangle. The bottom triangle here is going to be half of the bottom rectangle here, and therefore their sum will be half of the whole rectangle, which means that the sum will be the total sum of these two triangles will be 50% of the total rectangle. So if this is 15%, in that case this one is 50% minus 15%, which is 35% of the rectangle. Okay, so 35% of the rectangle corresponds to 175 square centimeter. Okay, therefore 100% will be 175 divided by 35 into 100. Correct? And this is 5 times. So the entire rectangle is 500 square centimeters. I hope this part is clear. All right. The entire area is 100 square centimeter. All right. 500 square centimeters. Sorry. All right. Now it says find the minimum possible perimeter of the rectangle. So this is the area of the rectangle. Okay. So for minimum possible perimeter, okay, with integer sides, what we need to do? We need to understand that the perimeter is equal to 2 into length plus width, and the area of a rectangle is length times width. All right. So let's break down the area, which is 500 here, into product of two integers, because it's given very clearly that the sides or lengths are integer values. Okay. Two integer values. 500 is not a square number. Correct. 500 is not a square number. So we cannot, make it a product of two same numbers. Okay. So 500, how we can make it as close to each other? So maybe a 25, let's say the length and width, we can have a 25 times 20. Okay. And that will give me an area of 500. And the perimeter in that case will be 45 times 2, which is 90. Okay. Length plus width multiplied by 2. What else I can do? Maybe, if I double this, okay, 40, if I double this, so if I make this 50 times 10 is another way of looking at it. You'll notice that the perimeter in that case will become 50 plus 10 times 2, which is 120. So it increases, correct? All right. What else we can do? We can maybe do this as 500 is also divisible by 4 and 5 as well. So if I take this as 5, so this one becomes 100. 100 plus 5 into 2 is 210. So you see, it's complete. It keeps on increasing. The perimeter keeps on increasing as we kind of make one side much larger and the other side smaller to have the same area. So when the side lengths are closer to each other, which means that the rectangle is more squarish, okay, then the perimeter is least, okay, for a given area. Okay. So the answer over here in this case, because we are looking at a least minimum possible perimeter of the rectangle, the answer will be option A, which is 90. We saw here that this is the closest the length and the width can be, 25 times 20. Right? So the answer is 90. Okay, so let's move on to the next question. Question 10. There are 30 one-digit natural numbers lined up in a row. So there are a lot of conditions in this question, it seems. There are 30 one-digit natural numbers lined up in a row. If you randomly pick up any 4 consecutive numbers from the row, which appears one after the other in the row, the sum of those numbers will be always the same every time. The 17th number is exactly half of the 28th number. The 10th number is the smallest and exactly one third of the 20th number. The 23rd number is the sum of the 5th number and the 14th number. Find the sum of the 30 natural numbers. Now let's understand. If it says that there are 30 numbers and if you pick any 4 consecutive numbers in a row, if you pick them up, the sum will be always same, which means that this is a repeat. The numbers are arranged in a repeating pattern of 4 numbers. Okay, it's arranged in 4 numbers. Then only the sum will always remain the same. Let's understand this. So let's say if I put 4 numbers, or let me put 4 numbers here, any 4 numbers, 5, 7, 3, 8. Okay, so if you start counting from 5, let me write this 5, 7, 3, 8, 5, 7, 3, 8, like that in a repeating way. Okay, what happens is that if I start adding from 5 and I'll take all 4 of them, and the sum will be, in that case, will be 23. 5 plus 7 plus 3 is 15 plus 8, 23. Now, if I start adding from 7, which means I'll leave the 5, but I go up to 5 because I have to take 4 numbers again. Then, which means I'm taking the same 4 numbers again, but it is in a different order. But the sum will remain the same because it'll be still adding the same 4 numbers. So that's exactly what happens when it says that the sum of 4 consecutive numbers are going to be same. Okay, which means that the first pattern, it will keep on repeating. And because there are 30 numbers, which means in the last pattern will be incomplete because 30 is not a multiple of 7. But yet, if you take the numbers, let's say the 27th, the 28th, 29th, and 30th number, for that particular block of numbers also, it will be still the same number. All right. So we'll need to figure that out, and we need to look at this. Okay, so let's make this quickly. Kind of this thing, numbers here. So this one here is 29th and this one is 30th. All right. Okay. Now it says the 17th number is exactly half of the 28th number. Now understand, because it's a repeating pattern which has got a pattern size of 4, the 28th number will be same as the 4th number. Why? Because 1 to 4, if you take blocks of 4, 28 is exactly divisible by 4. Therefore, the 28th number and the 4th number will be same. So let's say this is the 4th number. So N1, N2, N3, and N4. So N4 will be same as N28. Okay. So this will be the same number. And it says that it is exactly half of the 17th number is exactly half of the 28th number. Now the 17th number will be the first, equal to the first number. So this is the 17th number here. 17 and 17 will be also same as N1. All right. It will be same because if you take up blocks of 4, at 16 the pattern ends and 17 the pattern again starts. Correct. So in that case, so we can say that the 4th number is going to be double of the first number because the first number is half of the 4th number. Now it says the 10th number. The 10th number, when you divide 10 by 4, you get a remainder of 2. So that is equivalent to the second number. So N10 will be same as N2. Okay. It's the smallest and exactly one third of the 20th number. So the 20th number here, okay, the 20th number here is again going to be, because it's again divisible by 4, will be same as this one, N4 and N28. Okay, so what does it say? That the 10th number is smallest and one third of the 20th number. So the 20th number, the N4, as we know, it also said that what? It was double of the 17th number, right? So the 4th number is double of this, so it's a multiple of 2. Okay, and it is also a multiple of 3. Why? The 10th number is the smallest and exactly, sorry, the second number is and one third. So this is also a multiple of 3. Then only you can divide it and get it to this thing, because all the numbers are natural numbers, right? So it is also a multiple of this thing. Now it says the 23rd number is the sum of the 5th number and the 14th number. Okay, a lot of conditions. Okay, so let's write down the conditions instead of doing this. Okay, so we are saying that N4 is equal to N28 is equal to N20. Okay, and this is N20. Okay, and these are multiple of 2. Why? Because they are double of N1 and multiple of 3 also. These 3 numbers. All right. Okay. Now we see N17th is half of, so the first number and 1/3 of the 20th number, 10th number. The second number is 1/3 of this thing. 23rd number is the sum of the 5th number and this thing. So the third number here, the third number N3, which will be also equal to N23rd. Why? Because when we divide by 4, both of them will give you a remainder of 3. Okay, is the sum of the 5th number, which means it's equal to the first number. The 5th number is same as the first number, and the 14th number. The 14th number is also the second number. So N1 plus N2 is equal to N3. Okay, and it says that the N4 is double of the N4. The N4 is 20, the 17th number is exactly half of this thing. The N4 is double of N1. So this is equal to also 2 of N1 and is also equal to 3 of N3. N3, right? And that is the smallest, is 1/3 of the 20th number. Sorry. 3 of N2. The fourth number in the pattern is double of N1 and 3 of this thing. So the number which is both divisible by 2 and 3, and they are all single digit numbers, there is only one natural number like that. There's only one natural number like that, and that is 6. Correct, because if you look at the second common multiple of 2 and 3, that is 12, which is a 2-digit number. So we found out what is our N4. So our N4 is 6. And therefore, our N1 is going to be half of it, which is 3. And our N2, therefore, which is 1/3 of 6, is going to be 2. All right. And it also says our N3 is equal to N1 plus N2. So this is going to be 5. We found our pattern of 4 numbers, 3, 2, 5, 6. All right. Now, what is the sum of these two patterns? Now, understand that because we have 30 numbers, there are 7 full patterns, and the last 2 numbers will repeat. So this will be 3 and 2 again. So this will be 29th will be same as N1. All right. So now let's look at the pattern here. What is the sum over here? This is 5 plus 6 is 11. 11 plus 5 is 16. Okay, so this is, we have 16 here. And there are 7 full patterns, because when you divide 30 by 4 blocks of 4, you will get 7 as a quotient and remainder here too. Correct? So those 2 numbers are 3 and 2 here. So we have 7 patterns of size whose sums are 16. Therefore, the total value, the sum here, will be 7 times 16 plus 3 plus 2, which is 5. All right. 7 times 16 is 112, if I'm not wrong. Okay. And plus, we have to add 5. So we get an answer of 117. And that's our answer. This number was more on logic and understanding the relational aspects. Okay. So our answer is B, which is 117. Okay. So we move on to the next question. Application ability, question 11 to 20, 4 marks each. Okay, this is the first question from that section. Question 11. Natural numbers starting from 1 onwards are written in a rectangular grid. One of the examples shown here below, although it might not fulfill the condition given below. Okay. And you can decide the number of numbers in each row. In how many ways different number of numbers in each row can you create a grid So that 13 and 85 are in the same column. If you go down vertically from 13, you will find 85. That means that they are in the same column. Okay. Note that you cannot have only one number in each row, where obviously all the numbers will appear in a single column only. Okay. What it means basically is that the question means is that, let's say you make a grid like this, 1, 2, 3, 4 only. Here the example is shown for 5. Let's say we write like this. So if you then have 5, 6, 7, 8 like that, okay, then the 13 and the 85 should fall in the same this thing. Right? This is the concept about this thing. So let's say if we are dividing a number by 5, okay, you will notice that if you make each row has 5 numbers, okay, when you divide any of these numbers, they will have the same remainder if they are in the same column. So when you divide 3 by 5, you'll get a remainder of 3. Divide 8 by 5, you'll get a remainder of 3. Divide 13 by 5, you'll get a remainder of 3, and so on and so forth. Why does this happen? So let's say each row has n numbers in each row. So any number can be expressed. Okay, so and let's say this particular column. So if there are n numbers here, so when you divide the last number here, the last numbers here, they will give you a remainder of 0. The first number will give you a remainder of 1, remainder of 2, remainder of 3, and so on till remainder of n minus 1. Correct? All right. All these numbers will be this. So let's say a particular remainder is r in a column. Okay, some remainder r. We don't know the value of r, but r is less than n. Okay. In that case, what happens that a particular number here will be, let's say this a number here, let's say a1. Okay, and a1 and some ak, they are in the, or let's say am and an, they are in the same column, which means they will have the same remainder when divided by 5. So let's say, or divided by n. So let's say that the value of am is na plus r. Okay, n times some quotient a plus r, and an is equal to n times some b plus r. So when you subtract them, and an is greater than am. So an is, as you can see, is lower than that am in the grid. It will be a larger number. So when you subtract them, what will you get? You will get n into b minus a, and the r and r will cancel. Correct? Okay. Now b minus a will be some quotient, some integer only, because both are quotient, right? And therefore this n is basically a factor of the difference of these two numbers. So n times this is equal to a n minus am, and therefore n is a factor of this thing, right? So as long as it's a factor, it will appear in the same column, right? So the n will decide the kind of grid we are making in here, right? So what all we need to do, we know that the 13 and 85 will fall in the same column, which means that if they are divided by n, okay, they will have the same remainder, which means that their difference is a multiple of n. Correct. So if we subtract 85 minus 13, what do we get here? We get 72. Correct. So that number will be a factor of 72. Correct. So factors of 72, as you know, 72 can be prime factorized in the form of 8 into 9, which is 2 cube into 3 square. And therefore the number of factors is going to be number of factors for 72 is going to be 4 times 3, which is 12. Right? Okay. So now what we are going to do is that we will take all the factors except 1, because if we take 1 as a factor, which means n is equal to 1, which means that only one numbers is there, which is not allowed in this question. Okay, which means that if you write 1, 2, 3, 4 like this, so we are taking only single numbers in each row. Therefore, obviously 13 and 85 will fall in the same column. Okay. But if we take n is equal to 2, because the factors of 72, 12 here, so let's look at what all factors we get. Okay, so if you just make pairs, 1 and 72, 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and then 8 times 9. So you have these 6 pairs of factors, out of which one you cannot take, but all the others you can take. For example, let's take two extreme cases, 72 and 2. Okay, so 72 means that each row will have 72 numbers. Therefore, 13 will appear in the remainder 13 column. And when you divide 85 by 72 also, that will also appear in the remainder 13 column, because 85 by 72 gives you a remainder of 13. Here the quotient is 0, here the quotient is 1. Similarly, if you take 2, which is another example, in that case, because both 13 and 85 are odd numbers, they will both give you a remainder of 1 when divided by 2. Correct. So if you write 1, 2, 3, 4, 5, 6, if you keep two numbers in each row, as you can very clearly see, all the odd numbers will appear here. So the 13 and the 85 will appear in the same column. Okay, you can take any other example also. Let's take another one here for 12. Okay, so if you take 12, then the 13 will give you a remainder of 1. And the 85 also, if you notice, if you divide by 12, will give you a remainder of 1. What about 18? If you divide 13 by 18, your remainder will be 13 itself. And when you divide 85 by 18, again your remainder will be 13 itself, because 18 times 4 is 72, and then 13 will be remainder. Okay, so the remainder will be same when you divide by in each case. They might be different for different numbers, but they'll fall in the same remainder column. So I hope you understood the concept. Okay, so the difference of two numbers, okay, given a difference of two numbers, will have the same remainder for all the factors of the difference, correct? The two numbers when divided by n will give the same remainder, okay, where n can be a factor of the difference of both the numbers. All right, so that's the concept. Okay, so the answer here, as we saw, is going to be, so except 12, okay, we can consider all the others, which means your answer option is D. Sorry, except 1. Out of these 12 factors, we cannot consider 1 as it's given in the question. So therefore, it will be, the answer will be option D, 11. Right, we'll move on to the next question. Question 12. If a cuboid's length is increased by 3 centimeter, its surface area will increase by 108 square centimeter. If its width is increased by 4 centimeter, then the surface area will increase by 160 square centimeter. If its height is increased by 5 centimeter, then its surface area will increase by 220 square centimeter. Find its original volume. All right. So let's first understand what are the formulas. Okay. So if, let's say, this is a cuboid which is given here, okay, and this part is the length. So this is L, right? And this part here is width, which is W, and this is H, right? So the volume here, first of all, is L times W times H. It's a product of all the three dimensions, right? That is the volume of the cuboid. At the same time, the surface area of the cuboid is 2 times L into W. So L into W is this top surface, and the bottom surface will be also same, L into W. So there are 2 times L into W. Plus you have the right side, which is W into H, and the left side is also W into H. That will be W into H. And if you look at the front and the bottom, front and the back one, they are going to be, the front is, this side is the front, and the back side is over there. So the back side is going to be L into H. Because there are two surfaces, opposite surfaces of the same area, this will be what will be the surface area. Now understand, if the length is increased by 3 centimeter, so the new surface area will become what? 2 into L plus 3 into W plus W into H, because W and H remain the same, and you have L plus 3 times H. This will be the new volume. Sorry, new surface area. Surface area, new. when the length is increased. When the length is increased. All right. So if you subtract from this one to that one, all these will cancel out. These two will cancel out. Okay, and it will be basically 2 into 3 into W plus H. All right. If you subtract this, you will get this 2 into 3. Because what is going to happen? Try to imagine this without the formula also. If the length is increased over here, so this surface area over here has increased to what? Is increased by only this part, right? And this part is how much? This part is L into H. The increase in length, which is 3 into W. 3 into W, and the same will be increased over here also. Okay, so it will be again 2 into 3, 3 into W. It will be 2 into 3 into W. And similarly for the height as well. Okay, what will happen? That this surface area over here will increase by this part, and which is 3 into H, and the back side also it will increase by this much, correct, which is 3 into H, right? So this is the increase of the total surface area if the length is increased by 3 centimeters. And this is given as equal to 108. All right. Therefore, we can say W plus H is equal to 108 divided by 2 into 3, which is 6, is 18. In a similar way, the two other cases which are given when the width is increased by 4 centimeters. If the width is increased by 4 centimeters, then 2 into 4 into L plus H. Okay, we are taking the other two dimensions, as here also there was an increase in length by 3, so we took the other two dimensions. Here it will be L plus H, and this is equal to given as 160. 160 is the increase. All right. Therefore, L plus H is equal to 160 divided by 2 into 4, which is 8, will give you 20. All right. Okay. In the similar way, when we increase the height, okay, when we increase the height by 5, okay, what do we see here? We'll get here L plus W. And L plus, this is given as 220. And therefore, L plus W is equal to 220 divided by 10, which is 22. No, sorry, 22. So now we have 3 equations. All right. We have 3 equations from which we can find, and there are 3 variables as well. So length plus width is given as 22. Width plus height is given as 18, and length plus height is given as 20. Right. We can find this by comparison also, but there is an easier way because it's all symmetrical in nature, these equations. We can add all these up and we'll get 2 times L plus W plus H, because there are 2 L's here. Okay, there are 2 W's here and there are 2 H's here. If you add them up, you'll get 40 plus 20, which is 60. All right, therefore, L plus W plus H will be 60 divided by 2, which is 30. And from here, we can find out the H. The H here in this case would be 30 minus 22, because L plus W is 22, so H is 8. All right. Similarly, the W will be in that case, because W plus H is 18, therefore W will be 10. And similarly, now L will be equal to, L plus W is 22, therefore L will be 12. All right. And from here, we can find out the volume, because the volume, as we saw, is L into W into H. This is going to be 12 into 10 into 8. And that's 80 times 12. And that is 960. So 960 will be the answer of this question. So let's see what is the answer over here. 960 is option B, and that's your correct answer. Right. I hope it's clear. It has to be solved in a systematic way. All right. So let's look at the next problem. Question 13. There is a magic pond where if you put some coins in the morning, the existing coins become 3 times at night on the same day. For example, if you put 1 coin on day 1, the coins will become 3 coins at night on day 1, 9 on the second day night, 27 coins on the third day night, and so on. Savita started putting 5 coins in this magical pond every day in the morning for 4 consecutive days. Next morning on the 5th day, she took out all the coins. Find the total profit in terms of the number of additional magic coins she got back from the pond. Okay. So we see here that the coins triple. Sorry, they triple every day. Correct. Whatever coins are there in the morning. Okay. By night it triples. All right. So day one, Savita put 5 coins. Correct. These coins are the inputs. Okay. So 5 coins she put on. So day two, this coin will become 15. Correct. Day three, these coins will become 45. And day four, these coins will become 135. All right. 45 times 3. Okay. And day 5 morning she takes out. So for these 5 coins, she'll be able to get this much. What about what she put in on day 2? Day 2 also she's putting in 5 coins. Okay. If she puts in 5 coins, then this one will become 15 and this one will become 45. Right. Day 3 again she puts 5 coins and these coins will become 15. Right. And day 5 she puts again 5 coins. All right. 1 second. Huh? So this is the coins on the next morning. So the 45 is next morning for these 5 coins. 45, 135. All right. And on day 5 morning, these coins will become 135 times 3, which is going to be 405. These coins will become 135 coins. These coins will become 45 coins. And these coins, when she puts 5 coins on day 4 morning, will become 15 coins. So let's see what is the total here. 405 plus 135 is going to be 540. 540 plus 45 and plus 1560, and so that's equal to 600 coins. Now, how many coins did she put overall? The input coins, as you can see, are these 5 coins, right, every day. On the 5th morning, she did not put any coins. Okay, so the input coins are 5 times 4, which is 20. You subtract that, her total profit is going to be 580 coins, which is option E. Right. This is also a geometric series basically. What you can do is that you can add up all these three, all of them. Okay, so you can say that okay, it triples here. So your initial value is 5. The next one is 15 plus 45 plus 135 plus 405. All right. So of this geometric series, the total you get. You have to do a total at for every stage here. Okay. So the total here is going to be 20 here. The total here is 5 plus 20, 15, 20 plus 45 is 65 here. The total here is going to be at this stage is going to be 200, and this one over here is going to be, if you add all of these up, 405 and 540 is 605. You need not add this one. Right. If you look at it, this one you'll have 20 here. So this one is here. Here you notice. Okay, no, you need not do it in this way. Sorry about that. You can ignore this. All right. Plus 5 into 3 plus 5 into 3 square plus 5 into 3 cube plus 5 into 3 to the power 4. If you look at these figures here, the coins which were there in the beginning, okay, this is 5 into 3 to the power 4. These are plus 5 into 3 to the power 3, plus these are 5 into 3 to the power square, and plus 5 into 3 to the power 1. You need to add these numbers, okay, and using the formula here, what you can do is that, okay, so you can say, okay, I'll keep 5 as common, okay, and I have to add 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus 3 to the power 4, right? Now in a geometric series, when you are adding, so you have 3, 9, 27 and 81. If you are adding this, you can always multiply because the common ratio is 3. You can multiply. So let's say the sum of this is s. You multiply by the common ratio. So 3s will be equal to 9, 27. So if you're adding these up, okay, 27. So 9 here plus 27 plus 81 plus 243. Okay, when you subtract from second equation to first equation, you will get 2ss. So all these will cancel out and you will get 243 minus 3. Therefore, s is equal to 240 divided by 2, which is 120. All right. So the sum will be 5 into 120, which is 600. And you know the input values are going to be 5 days, 5 points each. So minus 20 will give you 580. And that's your answer. You can use the geometric formula also, but the easier way to do is to just simply add this because these are very few numbers which needs to be added. All right, so we'll move on to the next question. Question 14. Albert, Bernard, and Charles are three cousins. When Bernard was twice the age of Albert, Charles was 30 years old. All right. When Charles was twice as old as Bernard, Albert was 3 years old. What will be the Bernard's age in years when Charles will be twice as old as Albert? All right. So this is a little tongue twisting kind of a question, but it's an interesting one. Okay. So let's first understand the question a little bit and decipher what is the order of their age in terms of increasing order, who is the eldest and who is the youngest. Okay, so when Bernard was twice the age of Albert, so that means very clearly that Bernard would be definitely elder than Albert. So I'm using the greater than symbol for showing a larger, number for their ages. Okay, and when Charles was twice as old as Bernard, which means that Charles would be definitely older than Bernard as well. So if Charles is older than Bernard and Bernard is elder than Albert, in that case, Charles is definitely older than Albert as well. Correct? All right. Now, looking at these conditions, let's see that how we can do this question. Okay. So one thing in age problems you need to keep in mind is that their difference of age is always going to be the same. All right. So on the number line, let's say there's a number line here. Obviously, at any given point of time, Charles is the eldest. Correct. So when Charles was 30 here, as is it given here, okay, Bernard was twice the age of Albert. So let's say Bernard's age here was, or Albert's age here was X. Okay, in that case, Bernard's age would be 2X. This is, we are talking about the first condition. All right. So this is our starting point and this is our basis. We take the first statement as the basis of forming the equations. All right. In that case, we can see here that the difference of their ages, okay, that is C minus B, is equal to 30 minus 2X, which is always going to remain consistent. And the difference between A and B is 2X minus X. So B minus A is equal to X, which is 2X minus X. Right? All right. Now, when Bernard was twice the age of, then when Charles was twice as Albert was 3 years old. Now, let's take the same another number line here. Okay, and let's understand this. Take that as the basis. So Albert's age here, it is 3. Okay, so what will be Bernard's age using this equation? Bernard will be X years older than Bernard, so Albert, so it will be 3 plus X. Correct? And therefore, Charles was twice old as Bernard. So Bernard here, so Charles at that time will be twice as old as this. So if I multiply this by 2, I'll get 6 plus 2x. Correct? All right. Now, what is the gap here now? The gap here will be the difference of their ages, which means that if I take 6 plus 2x and I subtract 3 plus x, what will I get? I'll get 6 minus 3, which is 3, and plus 2x minus x will give me 3 plus x again. So this difference of their ages will be 6 plus 2x minus 3 plus x, which is going to be 3 plus x. This is also 3 plus x. Now these two differences are going to be same, so we can equate them, right? Because the difference between two people ages always remain the constant. So 30 minus 2x is equal to 3 plus x. And that gives us that 27 is equal to 3x. And therefore, x is equal to 9. So here we get some relationship, and from this we can find out from the first equation itself that when Albert was 9, Bernard was 18, and Charles was 30 years old at that time. Okay, so the difference between Albert and Bernard's age is 9 years, and difference between Bernard and Charles is 30 minus 18, which is 12 years. All right, so we got this much. Now it says that what will be Bernard's age in years when Charles will be twice as old as Albert. Okay, now what is the difference between Charles and Albert's age? That is 12 plus 9, which is 21 years. Right, so now let's look at this. So Charles and Albert is 1 block and Charles is 2 block, correct? All right, because Charles is going to be double of Albert, right? Now the difference here, we saw that the difference here is 21 years, right? Because Albert and Charles difference is 21 years from the first conditions we can see here, right? So this difference of 1 block is going to be 21. 2 blocks minus 1 block is 21. Therefore, Albert's age will be 21 at that time and Charles' age will be 42. All right. Now, when Charles' age is 42, at that time, what will be the age of Bernard? Bernard is 12 years younger than Charles. Okay, so at that time, Bernard's age will be 42 minus 12, which is 30 years. So you can see that the difference of Albert and Bernard is still 9. The difference of Albert and Charles is 21. And you can also see that Bernard and Charles' age difference is also is 12, of course, because we have derived from that there only. So the correct answer for this question is option D, which is 30. There are many other ways also you can form the equations. I've just shown you one of the ways of doing it. You can take any other condition also and try and form the equations and solve this question. All right. Okay. We'll move on to the next question. Question 15. There are two candles of same height, but one is thicker than the other. The thick candle burns slower than the thin candle. Of course, because it has got a larger cross section, it has more wax, correct? Because if the heights are same, then the candles which are typically cylindrical in height, shape and shape, so it will take the height of the remaining candle is 3/4 in height of the remaining thick candle. At 10:30 p.m., the thin candle is completely finished. At what time the thick candle will finish? Assume that the different burning rates of the two candles are consistent throughout. Okay, the burning rate is same. It is just that in terms of in terms of its height, yes, the burning rates will be different. Okay, the burning of wax rate will be same. Okay, all right. So, anyways, let's look at how to tackle this question. Okay, let me make the question a little smaller so that we get a little more working space. Right, so let's understand this. So you have a thin candle here, okay, and you have a thick candle of the same height. All right, they were both lit. They were both lit at the same time at 7 p.m. Okay, at 9 p.m. we took a stock of the things. It was observed that it was is 3/4 in the height of the remaining thick candle. Okay, 3/4. So let's divide this into three parts: 1, 2, and 3 here. Okay. So let's say whatever was left, this one was left at 9 p.m. So obviously, in that case, this will be one part more height, correct? Because the height is this. So if this is 3h, then the height over here will be, of the thick candle, will be 4h. All right, the height over here will be 4h. Right, what is left at 9 p.m.? So at 9 p.m., this is what is left over here. All right, at 10 p.m., this entire this thing is completely finished. Okay, the thin candle is completely finished. It's completely burned out. Now let's understand, from if we look at the starting point, which is 7 p.m. for both of them. Okay, from 7 p.m. to 2 p.m., the time here is 2 hours. And from 9 p.m. to 10:30, sorry, this is given as 10:30, my mistake. 10:30 p.m., this is 1.5 hours. What is the ratio of the time? The ratio of the time, if you notice, it is 4:3. If 3 parts are remaining, so 3 parts are burned in 1.5 hours from 9 to 10:30. Okay, then in 2 hours, in these 2 hours, 4 parts would have burned. Correct? Another 4 parts. Okay, so, and these two heights are same. So here we can say we can divide this also into 3 more parts, or sorry, 4 more parts. 3 more parts here, right? So we can divide this into 4 more parts. So what was left here? Okay, what was left here at 9 p.m. would be this part, and what was left here would be this part of the thick candle. All right. So how much did it burn? How much did the thick candle burn out of these 7 parts? Is only this much, which is 3 parts out of the 7 parts. So 3/7 of the thick candle burned in 2 hours. So how much time it will take to burn the whole candle? So 7/7 of the thick candle will take how much time? Will take 2 divided by 3/7 multiplied by 7/7. Okay, that is 2 into 7/3, and that is equal to 4 hours, 4 whole, that is 14/3, which is equal to 4 whole 2/3 hours. 7/7 from the beginning, correct? Because we are not considering about the remaining 4/7. If we consider that also, then we need to add that time from 9 p.m. But since we are considering from 7 p.m. directly, we'll calculate the time from the beginning. So to burn the whole candle, it will take how much time? To burn 3 parts, it took 2 hours. So to burn 7 parts, it will take 2/3 into 7, which is 4 whole 2 upon 3 hours. And if we add that time to 7 p.m., 7 p.m. plus 4 whole 2/3 hours, 2/3 hours is 40 minutes, and 4 hours, if we add to 7, it will become 11:40 p.m. Okay, and that's going to be our answer. Okay, so our answer here is 11:40 p.m., which is option C. All right, so we'll move on to the next question. Question 16. Friendly neighborhood Aunt Patricia was making a strawberry shake for all the kids in the neighborhood. Her famous recipe was 20% fruit concentrate and the rest chilled milk. She put 800 ml of fruit concentrate and then accidentally added 6 liters of milk in it. And as a result, the shake became too thin. Then she added more fruit concentrate to adjust the concentration, but the concentration became 25% instead of required 20%. How many more ml of milk she must add this time to ensure that she gets the recipe right? All right. So let's make the text, the question a little smaller so that we get a little more working space. All right. So it says her famous recipe was 20% fruit concentrate and rest chilled milk. She put 800 ml of fruit concentrate. Okay. So let's see fruit concentrate, and this should be 20% always. And it says and the rest chilled milk. So if the concentrate is 100%, so chilled milk here should be always 80%. Correct. And total concentrate, total her shake should will be 100%. Right. Now let's see. Initially, she started with 800 ml of fruit concentrate. Ideally, if you notice here, the chilled milk should have been 4 times of this, because 4 times of 20% is 80%, should have been 3200. But what she put here, 3200 milliliter. But what she put here was 6 liters, which is 6000 liters. Correct. So she put 6000 here. All right. Okay. Which means that now the percentage is very small, because the total amount here is now the total amount of the shake is 6800, out of which only 800 is fruit concentrate, which is definitely not 20%. It is much lesser than that. So the shake became too thin. Then she added more fruit concentrate to adjust the concentration. Okay. But the concentrate became 25%. So now understand that now she is not adding chilled milk anymore. Now the total chilled milk is 6000. Now this is equal to, because the concentrate became 25%, okay, which means this one became 75% now. This one is 75% now. And therefore the rest will be your fruit concentrate. So how much is overall? If this is 75%, then how much is the remaining 25%, which is fruit concentrate, which will be 1/3 of 75%, right? So that will be total of 2000. Okay, so what she did basically, she added another 1200 of fruit concentrate. As a result, what happened? 2000 became the fruit concentrate, and 6000 was still the chilled milk, right? So this is 25%. This is 75%. And if you add it up, you get 8000, which is 100%. So 8000 is the total shake, 8000 ml. 8000 75% is 600, and 8000 25% is 2000. Right? Now she needs to reduce it. She needs to add more milk so that she gets the recipe right. Correct? She needs to add more milk. Now understand, now if this one has to become, now this one won't change because you're not adding any more fruit concentrate. You already have more than required. Okay, so this one is now become 20%. How will this become 20? If this becomes 20%, then what will be 80%? 80% will be 4 times of this, correct? So this has to come to 8000. This has to come to 8000, right? Which is 80%. And then only the total shake, which will be 10,000 ml, 100%. Okay, we'll have 80% of milk. So how much more milk was added? It was 2000 ml. Okay, and that's our answer. We do this problem step by step. Okay, understanding what is changing and what is not changing, and their mutual relationship in terms of ratio and percentages. This problem is a very easy problem. All right. All right. So the answer of this question is going to be 2000 ml, and the answer is option A. All right. So let's move on to the next one. Question 17. Mr. Singh took an education loan of 50,000 rupees from a bank at a simple interest of 12% per annum for 5 years to be paid at the end of the tenure. His neighbor, Mr. Pal, took a loan of 50,000 rupees also, but at a compounding interest rate of 10% biannually every 6 months for 2 years. Find the difference of the total amount to be paid by both of them at the end of their respective loan terms. All right, so we'll need a little working space. So I'm making the question a little smaller. All right. So Mr. Singh took the loan of 50,000 at simple interest per annum for 5 years. All right. So the total amount he'll be paying will be principal. This amount which he take as a loan is called the principal amount. He'll be paying principal plus interest. Okay, so principal plus interest can be calculated. The interest is calculated as principal into the rate of interest. The rate of interest is 12. Okay, so let me just write R only for the time being, into R, which is the rate of interest. So this is the R. Okay, and the time is 5 years, and this divided by 100. Right, so I can take P as common. I can say 1 plus, let me put T also here. T, the time, 1 plus RT by 100. Right, and now let's plug in the values over here. It will be 50,000 multiplied by 1 plus 12 times 5 by 100. So which is 50,000 multiplied by, this is 60 upon 100, which is 3 upon 5. Okay, so into 8 upon 5. 5 will go in this 10,000 times 8 is equal to 80,000. All right. So if you can look at this also, 12% per annum into 5. 12 into 5 is going to be 60%, right? Overall. So 60% of 50,000 is 30,000, and 30,000 you are adding to 50,000, which is the principal amount. You will get the 8,000 rupees. Now we'll calculate the Mr. Pal's overall repayment amount. Okay, so Mr. Pal here took the same amount. Okay, but he took it on a compounding interest of 10% biannually every 6 months for 2 years. So understand this, biannually means every 6 months. And in 2 years, how many 6 months are there? There are 4 6 months, 4 biannual terms, correct? Okay, but this is on compounding interest. So in compounding interest, the formula for this is P into 1 plus R upon 100 to the power T. Okay, this is what the formula for compounding interest is. I mean compounding amount is. All right, so we'll see this, what we'll get. We'll get 50,000 here. Okay, and 1 plus your rate of interest in this case was a little lesser, which was 10%. It will be 10 upon 100. But the term will be 4 years, 4 terms, 4 biannual terms. It won't be 2 years, so it won't be 2 because it's biannually. If it was annually, then it would have been 2. So here we'll get 4. Now this is 11 by 10. Okay, so 50,000 into 11 by 10 raised to the power 4 into 11 into 11 into 11 into 11 divided by 10 into 10 into 10 into 10. So all these zeros will cancel out for the 5. Okay, we need to find what is the value of 11 raised to the power 4. So this is 121 is 11 square times 11 will give me 121, 121, 1331, 1331 times another 11. So let's see what we get. 1331, 1331 will get 14641. So this times 5. Okay, so 14641 times 5 will give me 5, 22, 22 is 3, 23 is 2, 73205. All right. So apparently Mr. Pal, because of his short tenure and a little less, his interest rate also, although being on a compounding interest, is paying lesser. So let's see what is the difference of their amounts. So if we subtract this, 80,000 minus 73205, we'll get 5 here, 9 here, 7, 6. So it will be 6795. Okay, and that's option E. So that's your answer. 6795. That is the difference of the repayment amount. So it seems Mr. Singh is still ending up paying much more due to his high tenure period. But if you notice, This guy is paying the loans in just 2 years as compared to 5 years, but he's paying almost the same amount. It's just a little wee bit little lesser. All right. So we'll move on to the next question. Question 18. Ramu, the local coconut seller, sold two-thirds of his coconut at a rate so that he was able to exactly recover his cost price of all coconuts. At what profit percentage on the original cost price of each coconut should he sell the remaining coconuts to ensure a 75% profit overall on all the coconuts? Right. So this is an interesting question. Okay, let's see. And a little bit of logic has to be used. Okay, so if he's selling, two-thirds of his coconuts and he's able to recover the cost price, the rate at which he's be selling will be the reciprocal of 2 by 3, which is 3 by 2. Correct. Then only he's able to recover the cost price. Okay, so for example, let's take a basic example. All right, so let's say he bought 300 coconuts. Okay, and he bought it for 300 rupees. Right. Now to recover this 300 rupees, if he sold 200, so in this case, the rate of coconuts is what? One coconut is 1 rupee, correct? Correct. You can write this as 1 rupees per coconut. Right. Now if he's selling two-thirds of these coconuts, which will be 200 coconuts, and he's again getting 300 rupees, in that case his price is 300 divided by 200, which is 1.5 rupees per coconut. So you see here the relationship. If two-thirds of the quantity if he's selling and he's able to recover the cost, which exactly recover the cost, in that case he's selling it at 3 by 2 of the cost price of the coconuts. That is number one. All right. Now it is saying at what profit percentage on the original cost of each coconut should he sell the remaining coconuts to ensure a 75% on all coconuts. So let's first understand. Let's take this as an example only and solve this, because you can use arbitrary figures here. The reason being, this question does not have anything in terms of, it's all talking about percentages. So for 300 rupees, if I want to make 75% profit, then I need to sell it at 175% of the cost, correct? And that should be my total selling cost of all the coconuts. So 300 into 175 is equal to 300 multiplied by 175 by 100. And that gives us how much? 175 times 3 will give us 525 rupees. Okay. So now I've already sold 200 coconuts for 300 rupees, and Ramu has sold. So for the remaining 100 coconuts, he needs to sell at 525 minus 300, which means at 225 rupees. 225 rupees. Which means one coconut he will be selling at what rate? 225 divided by 100, which is 2.25 rupees. His original cost price was 1 rupees, correct? All right. So at what profit margin? Okay, at what profit margin on the original cost price of each coconut should he sell? So original cost price of the coconut was 1 rupee. Okay, and the profit margin on each coconut in that case will be 2.25 minus 1 rupee, which is 1.25 rupees. This will be the profit, correct, on each coconut for the remaining 100 coconuts. And therefore, the profit percentage will be 1.25, which is the profit, divided by the cost price, which is 1 into 100. Right? And that will give you 125%. So your correct answer over here is going to be 125%, which is option D. Right? I hope this is clear. Let's move on to the next question. A river rafting team covers the distance between point A and point B in 6 hours. When they go downstream, when they return upstream from point B to A, they take 10 hours. If the speed of the water is 5 km per hour, find the distance in kilometers between the point A and B. Assume that they can raft at the same speed throughout in still water. So what happens? Let's say somebody can raft at in a speed in still water. Okay. they have a speed. Let's say that is the boat speed. Let's call it boat. It's raft here, but we'll use boat speed. Okay, this is a still water speed, boat speed. But if it is going downstream, then the water is also supporting it. Okay, so its downstream speed becomes, let's say water speed is Ws, then the downstream speed becomes boat speed plus water speed. And in the same thing, if the boat is coming upwards, this is when it's going downwards. But if it's coming upwards, then the water opposes it, so its speed becomes boat speed minus water speed. That is the still water speed minus the water speed. All right. With these concepts, we'll try and solve this problem. All right. So first of all, we'll notice a few things here. That the time taken, so from point A to B and B to A is the same distance. Okay, so A to B, which is also equal to B to A, is, let's say, D. That's the distance. So for the same distance, while going downstream, it is taking 6 hours when it is supported by the water. Correct. So its speed is taking 6 hours. So time of downstream is 6 hours and time of upstream is 10 hours. So what is the ratio of time of downstream to time of upstream? Is 6:10. And therefore, because the distance is same, the speed will become speed of downstream to speed of upstream will be the reverse of it. Okay, because the speed is more here in this case. It will be 10 by 6. Because they are reciprocal of each other. They are inversely proportional. Right? And that is equal to 5 by 3. All right. Now, speed of downstream is going to be boat speed plus water speed, and speed of upstream will be boat speed minus water speed, and that is 5 by 3. They've also given what is water speed, right? Which is given here in the question, that the water speed here is 5 kilometers per hour. We can replace the value of water speed here. So B plus 5 by B minus 5 is equal to 5 by 3. Right, so we'll see here that then solving for this equation by cross multiplying, we'll get 3b plus 15 is equal to 5b minus 25. That gives us 2b is equal to 40. All right, and therefore boat speed in still water is 40 by 2, which is 20 kilometer per hour. Therefore, its downstream speed b plus w will become 20 plus the water speed 5, which is 25. And how much time it is taking? The time of downstream was, this is speed of downstream, right? And how much was time taken? Time taken was 6 hours. So the distance of A to B will be equal to speed of downstream multiplied by time of downstream, which is equal to 25 times 6, which is 150 kilometers. Okay, and that's going to be option B here. All right. There's another way to look at it. In fact, is without using the formula and finding the boat speed. The other way to look at it is that I will look at it as a number line. Okay, so let's see, this is the boat speed. All right, and let's say this is the water speed. So over here, this much is the water speed, this distance. So this one will become B plus W. And similarly, on this side, if I go W, I will have this one as B minus W. Now, we saw from this ratio relationship, this one is going to be 5 and this one is going to be 3. Okay, and they are at equal distance. So what will be B here? B will be 4. Correct. Because this is just exactly the midpoint of this. So this is going to be 4. If this is 4 and this distance of 1 is equivalent of 5 kilometer per hour, then what is 4? 4 will be 4 into 5, which is 20 kilometer per hour. And without using the equation, you found the boat speed, still water boat speed. And therefore, you know this one over here is going to be 25. Okay, and this one over here is going to be 20 minus 5, which is 15. And then you can check 15 times 10 is also 150. And 25 times 6 is also 150. And that's about it. All right. Okay. So let's move on to the next question. Question 20. A goat is tied to the corner of a house which has grass all around it. The rope is 14-meter long and the house has a square shape with sides of 7 meter. Find the total area in square meter where the goat can graze the grass, given the restriction that it is tied to one corner of the house with walls. Okay. All right. So let's make the working space a little larger and let's try and solve this question. All right. Let's first understand this. Okay. So let me draw a square here. Give me a second. All right. So here, let's understand the goat will try and stretch the rope as much as possible, correct? And that is 14 meters. Okay. So this is 14 meters. So let's say the goat is here. Okay. What the goat is going to do is that it will try and pivot around this point from where it is tied up and go in a circle and see how much it can graze. So if you look at this, the goat will keep on going, right? But here, if the rope goes straight from here, okay, if the rope is straight from here, okay, this point the rope will stretch because the rope cannot go like this, right? It cannot go pass through the walls, right? So it will start pivoting from here, from this distance, okay, in a circular way. So it will get stuck here. So you need to have a little bit of visualization with this problem. And similarly, the goat will from here also it will pivot, okay, at this point. At this point, the goat will go like this. Why? Because this is 7 meters, 7 meter, and this length is 14. So 7, so he'll be left with 7 meters. Okay, so it will go like this, correct? We'll be left with 7 meter here. So with a radius of 7 meter, it will pivot in a quarter circle here. Anywhere in this region, it can eat grass. Similarly, over here also, it will pivot over here. And anywhere in this region, it will eat grass. And all the way up to here, it will also eat grass. Right, so let me put all these regions in green. All right. So here we see here that the entire area of scope where the goat can travel is actually part of, you have two quarter circles here. You have two quarter circles here, this one and this one. Okay, these are two smaller quarter circles with a radius of 7, to the radius of 7. All right, and you have a larger 3/4 of a circle, of a large circle with a radius of 14. So you just need to add all these areas where the goat can graze the grass from. Okay, so what we are going to do is that we are going to use circles area formula and also the fraction of areas. So two quarter circles with the same radius will add up to make a semicircle, right? That is number one. Okay, so we're trying to make our equation a little easy. So circle's area is pi r square. So semicircle's area will be pi r square by 2. So we'll take the pi common. Okay, and we'll say it is into 7 square by 2. This will sum up for these two quarter circles, right? And then we are going to take again a pi. Okay, and this time it is 3/4 of a circle with a radius of 14. So it will be 3/4 into 14 square, right? So we can take the pi common and we can say this is 7 square by 2 plus we have 3 into 14 square by 4. All right. So the pi, it is given that in this question you can use the pi as 22 by 7. If you notice here, take pi as 22 by 7. So we'll use that later on. Let's keep it the way it is. Let's first sort whatever is inside the bracket. So we'll take the LCM as 4. It will become 2 times 7 square plus 3 times 14 square. Right? Now we see this one will become pi into 49 times 2 is 98 plus 14 square is 196. 196 times 3 will be 600 minus 12. which is 588. Okay, divided by 4 is equal to 22 by 7. Okay, multiplied by 588 plus 98, which is going to be 686 by 4. Now 7 goes in 630 90 times, and in another 56 it will go 5 times. Correct. And this one will be 2 and this one will be 11 here. So it will be 98, and this 2 can also go on this 49 times. Sorry, my mistake. So we can do this as 49 times 11. Is that correct or not? 11 and 2, and the 2 can go on this in 49 times. All right, yeah. 49 times 11, and that will be 490 plus 49, which should be 539. So 539 square units, whatever the unit is given, should be our answer, and that's option E. Okay, I hope that this one is clear. You understood the concept that why it will get string. So once the string is against the wall, this one will become the center, and now the goat can only move like this. Correct. All right. So let's move on to the next question. So question number 21, which also is the first question from problem solving section. Little Jack can climb steps by taking 1 step or 2 step or 3 step in one move. He climbs 10 steps to meet his neighbors upstairs, but he did not step on the 5th step as it was under repair. Okay, in how many ways he could have climbed the steps? By how many ways it means that in what order? Like let's say he took first one step, then 3 steps, then one step, then 2 step, or whatever. So in how many ways he could have done it? So let's understand a few concepts here, first of all. Okay, and we'll apply that on the step problem. If you reach a particular point here in 3 ways, okay, and if you reach another point here in 2 ways, okay, 2 ways. Let's say this is point A and this is point B. And if you reach here and from B to C, you reach in one point, and A to C, you reach in one way. So here you reached in 3 ways, here you reached in 2 ways, okay. In how many ways, either through B or C, if you are reaching, in how many ways you can reach to C? It will be 3 plus 2, correct? Because you'll either come from A or you'll come from B, right? So they are mutually exclusive ways, so you can add them up. 3 plus 2 will be 5 ways. Same concept we are going to apply here in a staircase problem. Okay, and we'll see how it works. All right. So let's say Jack is on step 0. Okay, he's on the ground floor here, which is step 0. And he can only start from here. So there is only one way to come here, right? So let me make some steps here, right? So from here to here, he can come only by taking from 1 step from here. He cannot take 2 steps and reach here, correct? There is only one way to reach here. Now, what about the second step here? The second step here, he can either come from here or he can come from directly from here by taking a 2 step, right? So he can come in 2 ways, which is 1 plus 1. So what is happening in the first step 0, this is only one way. In one way, you are taking 1 plus 1, 1 and 1. So 1 and 1. So that's one group, correct? Sorry, only one step. Second one, you're either taking from a 0 to, you're taking from here, you're taking directly a 2 step, correct? Or you're taking a 1 step from here, 1 plus 1. Similarly, at the third step here, so there are 2 ways to reach here, the third step. Now you've reached in 2 ways here, and from here to here you can come by taking 1 step, or you can come from here by taking another step, or you can take a direct jump from here. So one way is this one, okay? Then from here is also one way, and this is 2 times one way. So you add all 3, you get 4 ways, right? So basically, this will work like a Fibonacci series because you have 3 options here. So that's what you need to do to get to a particular nth step, how long will you take? Okay. What we are going to do is that we are going to make a table here. Okay, quickly. Let's see. Step 0, which is on the ground floor. There's only one way to be there. Okay, so let me write this S1, S2, S3, S4, S5, 6, S7, S8, S9, S10. Right? Now, there's one more condition given here, that he cannot step on the fifth step. The fifth step he cannot reach at all. Okay, so there's no way to reach there. So the number of ways over there is going to be 0. We plug in the 0 in advance only. Okay. All right. Now, step 1, he can come only from here. So it will be one way to reach here. Step 2, he can either take a one-step move here or he can take a double-step move here. So you add these two ways. You get 2. Step 3, because he can take one step, 2-step or 3-step, he can either take a one step from second step and come here. He can take a 2 steps to come here, or he can take a 3 steps to come here. Right? So he reached S2 in 2 ways. Therefore, overall it will be 2 ways from S2 if he is moving. 1 step, 2 times 1, and this one will be 1 times 1 and 1 times 1. So overall it will be 1 plus 1 plus 2, which is 4. Similarly for S4, either he'll come from here or from here or from here. So you add up these last 3 numbers. So what do you get? You get 7. S5 is 0. S6 we need look from S5 he cannot come because he's not gone to that step only. But still if we consider count that also, it is adding 0 only. It doesn't make a difference. So we just take this one and this one, we add it up and we get 11. 2 steps from S4 or 3 step move, 3 step jump from S3, 11. Similarly, here also, if we take the last 3 and we add it up, we'll get 18. Last 3, if we take, we'll get 29. Okay, last 3, if we take, we get 40 plus 58. All right, and the last one here will become 29 plus 18 will give us 47. 47 plus 58 will give us 105. So the answer will be option C, 105. All right, let's move on to the next question. Question 22. Adam and Beatrice are playing a matchstick game where each one of them have to take turns to pick up matchsticks. Each one of them have to pick up at least 3 or maximum of up to 7 matchsticks in their turn. The person who gets the last matchstick loses the game. There are 107 matchsticks to begin with, and Beatrice starts the game with her pick. All right. How many matchsticks should she pick up in her first turn to ensure that she would definitely win if she applies the right strategy? All right. Okay, let's understand this. Okay. The strategy in this is that you need to understand that let's look at the number of matchsticks one person can pick up. So the number of matchsticks you can pick up is either 3 or 4 or 5 or 6 or 7. All right. Now, what are the numbers you can make to complement whatever the other person is picking? Okay. So 3 plus 7 is 10. 4 plus 6 is also 10. And 5 plus 5, so 3 plus 7 is 10. Correct? All right. 4 plus 6 is also 10. And 5 plus 5 is also 10. Right? Now, understand that in the end, if the person who's losing, if it is that person's turn and there are 3 matchsticks left only, which is the least pick, okay, the person has no other option than to pick up these 3 plays because he cannot pick anything less than 3, he cannot pick anything more than 3. The person has to pick up 3, correct? Right? So that person will lose, correct? So if Beatrice is going first, okay, and Beatrice is going first over here. Okay, so if there are 107 matchsticks to start with, okay, how many matchsticks together they should have picked up that it is the number of matchsticks left is 3. So the total matchsticks which are picked up at the time when the person who is going to lose, which is the other person, what's the other person's name here? Adam. Adam is left with 3 matchsticks, will be 104 matchsticks should have been picked by then. Correct? All right. Now, Beatrice, understand, if she is at 100 and total matchsticks is 107. So if she picks up 3 matchsticks and it's Adam's turn. So if Beatrice goes first and she picks up in his first turn only 3 matchsticks, then there are overall 104 matchsticks left. Correct? Correct or not? Sorry, if she picks up 4 matchsticks, my mistake. If she picks up 4 matchsticks, correct, then if she picks up 4 matchsticks, then how many matchsticks will be left? 104 matchsticks are to be picked by both of them. If she picks up 4 matchsticks, then there are 100 matchsticks are left. And 100 is a multiple of these 10s. Correct. Now it's Adam's turn and Adam is going first. Correct. Adam is going first. So whatever Adam picks up, if Adam picks up 3, Beatrice can pick up 7. If Adam picks up 4, Beatrice can pick up 6. If Adam picks up 5, then Beatrice will pick up 5. And therefore, in every a pair of turns of Adam and Beatrice, where Adam goes first and Beatrice goes second, okay, this number will keep on reducing by 10s. And eventually, this will become 0. When this is 0, okay, understand. So Beatrice started with 4 matchsticks here. And then multiples of 10 and 100 matchsticks got over. So overall, 104 matchsticks would have got over. And then it will be Adam's turn. And if it's Adam's turn, at that time there are 3 matchsticks which are left, okay, which we saw from here. Okay, Adam will lose. He'll have no other option but to pick up those 3 matchsticks. So Beatrice would pick up 4 matchsticks in her first turn. Okay, and that's the correct answer. B is 4. Right? I hope this one helps, and maybe you can play this game also at home and understand this. Okay. All right. Normally, these kind of problems are not given from 3 to n matchsticks. It is given from 1 to 1, 2, 3, 4, like that. Okay. In that case, what you need to do, 1 plus 4 is 5. So you need to reduce it by 5's multiple. And then there are variations of this game also, where the person to pick up the last matchsticks can win also. In that case, the strategy would be a little different. Okay. In that case, the strategy would be a little different. Okay. All right. Okay, so let's go on to the next question. At least how many numbers will you pick up at random from numbers 1 to 100 to ensure that you have at least 2 such numbers whose product is divisible by 3? Okay, so if it is product, if the 2 numbers, let's say, are A and B, then A into B should be divisible by 6, which means that A and B, and 6 is 6, as we all know, is 2 times 3. So A and B should have in their prime factorization 2 and 3 put together. All right, so let's understand this question. There is a pigeonhole also involved in this. Okay, so first of all, how many multiples of 2 are there? So because we are dealing with 6, which is equal to 2 into 3, we'll see how many multiples of 2 are there from 1 to 100. So you know that 2's multiples will be 50 in this, right? All the even numbers starting from 2 till 100. How many multiples of 3 are in this? They are going to be 3, which means from 3 to 99, there are 33 of them. Okay, 33 times 3 is 99. How many multiples, common multiples would be there? So those will be 6, correct? 6's multiples are 16 of them. 16 times 6 is 96, right? So because these 6's multiple will appear in both of them, their counts, okay, we are going to subtract it to get the numbers which are either multiple of 2 only, or multiples of 3 only, or multiple of both. Okay, so we'll see. 50 plus 33 is 83, minus 16 will give us 67. So 67 numbers are there which are either a multiple of 2 or 3 or both 2 and 3, right? Which means there are 33 numbers which are not multiples of 3, which are not multiples of Either 2 or 3. 2 or 3, correct? So let's say if we have very bad luck and we pick up first all those numbers only. For example, let's take all the other primes apart from 2 and 3. They are also, not multiples of 2 and 3, right? And then there are combinations as well, there are squares as well, and all those numbers. Okay, so there are 33 numbers. So let's understand this. So let me make a big box here. Okay, so there are 33 numbers which are bad apples. So we first pick up our assumption would be that in worst case scenario, we pick up first, we pick up 33 numbers which are not a multiple of 2 or 3. These are those 33 numbers. Okay, now the numbers which we have, let's make a Venn diagram here. Okay, so there'll be some numbers which are divisible by 2. These are the numbers which are divisible by 2. Okay, and these are the numbers which are divisible by 3. And these are the numbers which are divisible by both. Right, and we found out all those numbers. So divisible by 2, there are 50 numbers. Right, divisible by 3, we have 33 numbers. And divisible by 16 are these numbers. Okay, which are divisible by both 2 and 3. Okay, which means the numbers which are divisible by 2 but not by 3, which are divisible by only 2, will be 50 minus the 16. So this part will be 34 here. All right, and similarly, the numbers which are divisible by 3 but not by 2 will be 33 minus 16, which is 17 here. This is the breakup of all the remaining 67 numbers: 34, 16, and 17. Right, now, which is the largest in this, which can still not give the 3 which we require for the divisibility of by 6, is this one. So let's say we are very unlucky. So first we picked up those 33 numbers. Okay, and then the numbers which are divisible by 2 but not 3. We pick up these 34 numbers. We have picked up how many? We have picked up 33, and then we have picked up 34. 67 numbers. Still there are no 2 numbers whom if we multiply, they'll be divisible by 6, because we still do not have the 3 which is required in them for them to become divisible by 6. 33 plus 34 number, 67. But now if we pick up a number, if we pick up something from here, only one number is enough. Correct? Because it is anyways a multiple of 6. So 6 multiplied by something divisible by 6 will be always divisible by 6. Here also, if you pick up also any one number also, it is good enough, because we already have 2's. Right? So 2 into that number, which is a multiple of 3, will give me a multiple of 6. Correct? So all we need is one more number for it to become divisible by 6. So therefore, my answer is 67 plus 1. This can come from either this one or this one. Doesn't matter. So it will be 68. And that's your correct answer. I hope you understood the solution. All right. So let's move on to the next question. The hypotenuse of a right angled triangle is 50 centimeter. What is the maximum possible area? All right. So you need to know a little bit of concept about the circle in this to understand this problem. Okay, so let me explain the concept to you first, and then we'll see. And you might wonder that why it is related to circle. Okay, so let's look at this. So let's say this is our circle. Okay, and this is our diameter here. Okay, which is passing through the center here. Oh, okay. Now understand that every right angle triangle. So every right angle triangle. Okay, if you take the midpoint of the hypotenuse, okay, and treat this as a diameter, okay, then you can pass a circle through all its vertices. You can pass all if the midpoint, if this is the radius r, and you treat the hypotenuse as the diameter, then the midpoint will divide the hypotenuse in two equal parts, and each one of them can be a radius. So this is like this. Okay, it will always pass through this. So the hypotenuse becomes the diameter. Okay, for every this thing. So let's say there's a circle like this in this particular case, and we are taking the same right angle triangle here, and we're taking this as the hypotenuse. Now let's understand this. So if we just join at any point over here and then join this, okay, this one will be a right angle triangle. Any point inside here will be an obtuse angle triangle, and similarly any point outside here and joining the end points will be an acute angle triangle. Okay, the points only on the circle with this as the hypotenuse will give me a right angle triangle. The points which are on the circumference of the circle. All right. All right. Now coming to this, what is the area of this particular triangle? In this particular triangle, this is, let's say, if this is the base and this is the height. Okay, we can do this. This is the base and this is the perpendicular as well. Into half will also give me triangle. But let's take this as a base and then try to calculate the area, which is going to be same. If we drop a perpendicular like that, so this one becomes the height, and the whole diameter here becomes the base. All right. Now we can see here very clearly that the point at which this height will be, the area will be equal to half into height into base. Okay, now the base is going to be same across for any triangle. So if I make another triangle here, okay, the base, if you use the same diameter or the hypotenuse of the right angle triangle as the base, it will be still same. But the height will vary because this height, as you can see, is larger. Right? Okay, the highest point of the side, and now why this is okay, the height at highest point will be the one which is falling as a perpendicular at the center itself. If it is falling on the center, then this length is also the radius r, and the base becomes 2r. Now this is the largest height you can have for this right angle triangle. The reason being, if you notice here, if this is the height, and if I join this line from here, this is the radius, this is again a right angle triangle. And we know our hypotenuse is more than the shorter legs of a right angle triangle. But in this case, what is happening? Okay, there is no hypotenuse only. There is only the height is itself the radius. Correct. Therefore, this triangle will be the highest, which will have the highest height, and which will be equal to the radius itself. Therefore, the largest right angle triangle with a given hypotenuse, which is diameter, is half into r into 2r, where the 2r is the hypotenuse. Okay, so that's what we are going to do here. So if the hypotenuse is 50, which means that 2r is equal to 50, and therefore, if this is also r, radius of the circle, okay, then r will be equal to 50 by 2, which is 25 each. Okay, and therefore the area of the triangle will be half into 50, which is the base 2r, into the height, which is r, which is 25, and therefore the max area will be equal to 25 times 25, which is 625. Note that with a given diameter, given hypotenuse of a right angle triangle, the maximum, if you notice this, what is the formula here? Half into r into 2r. Okay, so 2 cancel is r square. Correct. So the maximum, okay, and r is equal to the h by 2. So if you calculate this, r is equal to h by 2. Correct. So you'll calculate this, you'll get h square by 4. Okay, h square by 4. So the maximum area which you get is always h square by 4, which is, you can say, in our case, h was 50. So 50 square by 4, which is going to be 2500 divided by 4, which is 625. That will be always the maximum area. If you get a right angle triangle which says that its hypotenuse is something and its area is more than h square by 4, then the question is not correct. All right, so I hope you understood this. The answer over here is going to be 625, which is option D. All right, so let's move on to the next one. Question 25. Find the difference of the two times between 6 p.m. and 7 p.m. when the right hour hand and minute hand make right angle with each other. Okay, round off your answer to the closest minute. Okay, so we have to find the difference between the two times between 6 p.m. and 7 p.m., which is within 1 hour, when the hour hand and the minute hand make right angle with each other. Round off your answers to the closest minute. Okay, so we'll try and solve this problem and let's understand this. Okay, so let me cut this one first from here. Okay, and let me move this down. So let's understand. Right now at 6 p.m. Okay, what is the angle between them? It is 180 degree. Correct. Okay. Now which hand is faster? This is the minute hand. The minute hand, which is the longer hand. Correct. And this is the hour hand. HH. All right. So the minute hand is faster, of course, because it moves in 1 hour. It moves one whole circle, while the hour hand moves only from let's say from 6 to 7. Correct. All right. So how many degrees does the minute hand move? The minute hand moves in 60 minutes. It moves 360 degrees. So what is the speed of the minute hand? Minute hand. The speed of the minute hand is 360 divided by 60, which is 6 degree a minute. Correct. All right. What about the hour hand? If this whole thing is 360 degrees, so this angle here is only 30 degree. Correct. 360 divided by 12 gives us 30 degree. So in 60 minutes, the hour hand moves only 30 degree. So what is the speed of the hour hand? The speed of the hour hand is 30 degree divided by 60, which is 0.5 minutes, degree per minute. Right. Now, what is the relative speed? The relative speed of the minute hand as compared to the hour hand will be 6 degree minus 5 degree, which is, sorry, 0.5 degree, will be 5.5 degrees a minute. It is just like two cars trying to catch up. Only difference is that instead of a straight line linear distance, it's an angular distance. So the angular distance over here is 180 degree. Correct. And that needs to be reduced to 90 degree for the first time to meet. So for example, let's say some point of time, this one will be like this and this one will be like this. And this angle over here will be 90 degree. It has reduced the angle. The minute hand has reduced the angle with a relative speed of 5.5 degree per minute, right? So 180 degree minus 90 degree, that is the distance which has been covered already. Okay, that's 90 degree, right? Divided by 5.5. Okay, degree. That will give us the time, the first time from 6 p.m. Okay, so that will become 180 divided by 11, which is one whole. Okay, and then 7 is this thing, 76 and 76, 4 by 11. This is this in this many minutes. Okay, for the first time it will make 90 degree. I hope you understood this. 180 degree was the initial distance, 90 degree is the distance, angular distance when they are at right angles with each other for the first time. Therefore, the distance covered is 90 degree. Okay, 180 minus 90, and 90 divided by the relative speed is this much. All right. Now let's understand. The second time, now it will further reduce, and the second time, this one will be somewhat like this. But this one will happen when it will be close to 7 again. Okay. And this time the minute hand would have gone on the other side. So it was earlier on this side, now it has gone on the other side. So what is the relative distance it covered? It covered 180 degree, right? If you understand that aspect, then you need not do this aspect also. So basically, all you have to do understand that it is covering another 180 degree, okay, relatively, okay, 180 degree, and divided by 5.5 is the relative speed. So that one will give us 360 divided by 11, and that is 3, and then 30 is left, so 2 and 8 upon 11. Uh, yeah, 8 upon 11 minutes. That is it will take after it has made a 90 degree for the first time. So if you understood these two angles, that okay, the first time it will be like this and the second time it will be like this, all you need to do is to directly calculate the 180 degree. This step is actually not required. It is just for explanation purpose I explained this. Okay, you can directly take 180 degree, because if it's making 90 degree from one side, the first instance, you understand this, if this is the minute hand and this is the hour hand. Now both are moving, okay? Both are moving. Only thing is that this one is faster. In the second instance, this one will be a little bit on this side, and this time this one has moved on this side. So with relative to this, it has changed an angle of, it has covered an angle of 180 degree, because it was 90 degree on this side first, and now it is 90 degree on this side. So it is 180 degree. And with what relative speed? With 5.5 relative speed. So 180 divided by 5.5, you'll get this. This is 32 whole 8 upon 11. And the question is asking that you give us the nearest minute. Round off your answer to the closest minute. Now 8 by 11, when rounded off, will give you 1. So you need to add 1 to 32, and your correct answer will be 33 minutes. Right? I hope the answer, you understood the solution. And that brings us to the end of the paper. Okay, if you, I hope that you took a little bit of some learning from this, the solutions of these questions. I've tried to detail a reason and the concepts also as much as possible within the time frame. Okay, and if you like this video, kindly subscribe and press the the bell icon for notifications. And if you're from India, you can register for all the contests from at our website www.globalolympiadsacademy.com. GJMAT 22-23 phase 2 will be done in April. I would recommend you to register for it, because it's one of the most challenging exams. Thank you for your time. Bye bye.